Okay, so on number 11, it's 3x over x squared plus 3x minus 10, and then you're subtracting this, right? X plus 1 over x plus 5. Okay, the thing to remember is how do fractions work when you subtract? If I had 3 over 7 minus 1/3, I'd have to get a common denominator, wouldn't I?
Right.
Okay, so this one would need to be multiplied by 3 over 3, right? Because it needs to have a 21 on the bottom. And this one would get multiplied by 7 over 7. And we'd have 9 over 21 minus 7 over 21. And we could say, oh, that's 2 over 21, right?
Right.
So we're going to have to do the same thing over here. We got to get a common denominator. Here our factors were just numbers, but over here they're going to be, we got to think of all these things like this, don't we?
Does this thing get your voice in it?
Yeah,
too?
it's getting my voice
Oh,
on
that's
it.
cool.
So yeah, you can go back and listen to it. You
Alright.
can hear us talking. Okay, so now this right here, this is kind of like what we were working on Tuesday. We're going to have to factor it first. I want a common denominator, but I'd really rather not have it. I want it to be as kind of clean as I can have it, because I don't want to have this huge mess to kind of deal with. So what you do is you go ahead and we're going to, just like we did the other day, remember how we factored that bottom, things like that bottom expression into, you had an x and an x. Do you remember how to do the negative 10? Remember we were using, got to multiply to get the number on the end, the constant, right?
Right.
And we're trying, what would we be adding to try to get here?
Let's see.
You can't see if I tilt it here. You don't want that number in the middle, right?
Right.
Okay.
So it would be 7 7? No.
Well, you're trying to think, the easiest way to think about it is how can you multiply to get 10? There's 10 times 1 and 2 times 5.
Right, 2 times 5.
Okay, so we know 2 and 5 will work. It needs to be a negative 10, so one of them needs to be negative, and I want a positive 3. Which one am I going to put the negative on? The
negative 5, or negative 2.
Good, yeah, because a 5 and a minus 2 is how I always think of it, is 3. So remember, that's what we put up here. Oops, that's hard to read sometimes. That's a minus 2 and a plus 5, okay? Okay, now I can kind of see, that's x minus 2. Let me see if I can just write over it, x plus 5. Now, I can look and see what I need for my common denominator now. Because both of these have this x plus 5 here, don't they? Can you see it? Or just let me know if you can. But this one also needs the x minus 2 that we can barely read. So what I'm going to do is I got to get the common denominator. Let me go ahead on the next line just because it's hard to read. So the common denominator, just need that x minus 2 with the second term, and then they'd have the same thing. So I'm going to take that second term, get the x plus 5 on down it, and we'll multiply it by the thing that it needs, the x minus 2 over x minus 2. Okay, it's going to run into that. Okay, but so let me draw a line right there, okay? So now we got the same thing in the denominator, which is what we knew we had to do with the fraction. So the nice part is now we can just write our denominator as 1, x plus 5, x minus 2, it doesn't matter the order I write it in. Okay, but now I just need, if you remember when we subtract across fractions, we just, I'll need to multiply this x plus 1 times x minus 2 outright, and then subtract it from 3x, but you got to be careful here because you're subtracting all of that stuff. So we're going to have to kind of FOIL it or distribute it, however, whatever you learn to call that. So it would be what? X squared. And then the little smiley face thing, we talked about that the other day, didn't we?
Yes.
Okay, that's a 1x and a
minus 2. So that would be 1.
Or just a minus 1x, because it was a plus 1 and a minus 2, so it would be a minus 1x or just a minus x. And then we have what, minus 2?
Yes.
Okay. Now the thing that is tricky, since you're subtracting, you gotta apply that subtraction sign to everything, or it's the same thing as multiplying by -1. I don't know, how do you usually think about that?
Just, it applies to everything.
Okay, that's what okay. There's so many different ways to look at it, and it's kind of, how did you learn it, is the best way. I'm going to go to a new slide here. This is kind of a clunky app, but it's free. I'm into free apps. Okay. So, let's see. So 3x, and then it was, I wrote it down here so you can kind of follow along.
Okay.
Minus x squared, right?
Right.
And then minus x. And then what would the sign be on that -2? What would it, minus 2 would become
a +2.
Okay. And that's all over that denominator. Okay, so let's look at what we can kind of put together up there. Do you see any like terms up there?
Wait, what did we?
Okay, so I got all this mess up on the top, and you want to put terms together that'll go together, right? You want to kind of clean it up a little bit. And so like that 3x and that x, that would add up to 4x, right? And I got a minus. I'm going to put the -x squared out front, just because usually we put the biggest exponent first, and then you got, what, a 4x, so it's a plus 4x, and then plus 2. All over that x plus 5, x minus 2. Now, what stinks is that sometimes you have to factor that.
Right.
Because you may can cancel something out. Okay? So I'm going to take the negative out. I'm going to take a negative out of all those top terms, because it's hard to factor a minus x squared, right? So I'm going to say, okay, when you take the negative out, doesn't that just change the sign on everything? Because you're kind of dividing everything by -1. So it would be a positive x squared minus 4x, and then minus 2, all over that x plus 5, x minus 2. Okay, we can read it. And will that factor? I don't know. I thought maybe it would, but if you're trying to multiply to get a -2 and add to get a -4, I don't think that works. Okay, so if you can't do anything, we might could have stopped up here and said, oh, this is the answer.
Okay.
You always try to factor it, and sometimes you waste your time, but you never know what's going to happen.
Okay.
So let me cut that off. Come on. Now, can you explain back to me, looking at the problem, what was it that I did to the problem? What were kind of the big steps we had to do?
I had to factor it all out, and then, I could show you better than I can show you.
Yeah, that's fine. We had this x plus 5 here. Once you factored that out, we noticed that we had an x plus 5 in both.
Right.
So what did you do next when you had an x plus 5? You also had like an x minus 2 here. What did you do with that other term?
This one right here? Hold on, let me think. Hold on, what do we have over here? We have x plus 5.
It's on the front, yeah.
Go back to the...
It won't go back. Okay, here we go. So you want a common denominator, right?
Right, so...
What number would we need on the bottom?
4x over here on both.
Yeah, you need to put, this one needs a 4. We know we need a 4 here and here, right? And what's this one going to need?
A 3.
A 3. Let me write it. It's going to go over that 12, but...
Okay, 3.
That sounds like rain.
That's
that is rain. I think it's not the air conditioner. Okay, they both have an x squared, so that's good. Right?
Right.
Okay, and then we got y cubed here. This one only has y. What do you think I need to do to get them to be the same? Goodness. Sure, we're looking at this. We saw that we needed the 3 and the 4 on both of them. The x squareds were the same, so that was good. But we have this y cubed here. We only have one y here. So what do I need to do to get them to be the same?
Okay, so... we need to
yeah, we're going to multiply. It's just like we did the 4 over here.
Right.
This one needs 2 more y's, doesn't it? So it would be the same. So we need to, when we multiply this first fraction by 3, we also need to multiply by 2 more y's, don't we?
Right, okay.
If you can read that, but hopefully.
2.
If we do something to the top, we have to do it to the bottom.
Okay.
Okay, so now you have 8 times 3 y squared on top. That's what, 24y squared? And our denominator is going to be the same, so I'm just going to write it on underneath one time.
Okay.
Didn't we? So yeah, so now we've got 12x squared y cubed on both of them, right?
Right.
Okay. And this time we're adding. And all we had to do to that second fraction was multiply it by 4, right? Because it had everything else, it just needed that 4.
So it'd be 5, I mean it'd be 20.
20x,
And then 4. It would be 12x.
Yeah, it's the same thing, isn't it, right?
Oh,
and,
yeah.
And we could write it twice, but I just drew one line
Gotcha.
since we made it the same on purpose, right?
Okay.
Again, I'm not sure how picky your teacher would be, but I would think they probably want you to do this. Do you notice that 24, 20, and 12 can all be divisible by divided 4 out of them, right?
Right.
So I could divide 4 out of them. I'm going to show you. You can just say, you can just do this if you want to, and then I'm going to show you another way to think about it. If I divide 24 by 4, that would leave me with 6y squared. If I divide 20 by 4, it would give me 5x, right?
Right.
And if I divided the 12 by 4, it would be 3, right? Okay. So that's what I would have left if I reduced it. Now I just want, if you divide something out like that, you got to divide it out of every single number, and if it doesn't divide out of one of them, it won't work.
Okay.
Here's kind of the way you're thinking in your head. You're thinking I could factor a 4 out of both of these. If it came out of 24y squared, it would be the 6y squared that you see us writing here. And then we said 20 divided by 4 was 5x. So if I take the 4 out, it looks like this.
Right. Okay.
Let me turn this on. What you really did when you divided 4 out of everything was you could say, I factored a 4 out of that, I factored a 4 out of that, and they canceled out. And you see we got left what we would have had I just gone, ooh, they're all divisible by 4, let's divide 4 out by every single one of them. You can, but you don't have to. You can just think, divide the number that divides into every single number out.